The Mabalon company not only casts bells, it also manufactures bell frames and tower blinds, and repairs old bell systems. Here in the forge, 5 bells have been commissioned and in the process of being made. We will follow along over a few months' time and witness the making and sounds of each bell. The crucial week of work has begun. The molders must prepare the bell mold for casting. The crown has already been removed. The crane now lifts the bell casing. This illustrates the function of the grease layer. The casing can be easily lifted off the clay bell. The casing bears the chalk number 4 and a chalk diamond. The numbers on the molds determine the casting order, meaning this bell mold will be cast forth. The diamond marks the front of the bell with the inscription. The crown stands separately. The clay mold has now served its purpose, and Hans knocks off the clay layer. The graphite layer applied to the core makes it easy to remove, and the clay cannot be reused. At the same time, the mold is cleaned by hand, and with compressed air to remove the dust. The molder seals the core interior with iron separating plates. Then adds several layers of earth and then sand. Joseph fits the clapper holder ring, which will be cast into the top of the bell's interior. The clapper suspension must be precisely adjusted, so that the bell clapper sits exactly on the striker rings of the finished bell, to produce the perfect tone. He now coats the inside of the shell with graphite, paying particular attention to the letter impressions of the inscription. The bell core also receives a similar graphite coating. This is intended to prevent the cast metal from sticking. The first working day of the casting week ends with the flame curing of the shells, and the firing of the cores of all the bell molds. The graphite layers must dry quickly, and the molds should not be placed in the casting pit while cold. Assembling and burying the molds. Of the 5-part chime, the 2 largest bells are cast stationary in the pit. The molders must precisely measure the location of the remaining molds in the open spaces. Large molds don't like to be moved to avoid damage. The 3 smaller bell molds, on the other hand, were made on the floor of the foundry and are assembled in the pit. Under the watchful eye of the master bell founder, Joseph and Hans place the core of the A bell into the casting pit. The core must be positioned exactly level. For this purpose, it is wedged with wooden blocks. The molders fit the shell they made before, lowering it onto the core. The crown with the windpipe system must also be precisely positioned on the molds. The pouring hole and the windpipes are already sealed to prevent dust from entering the cavity of the bell mold. Now the crown is smeared with casing to make a seal. After the molds are in place, the casting pit is filled with topsoil, which the molders take from a side pit. The excavation takes place in 20 centimeters deep layers. The number of earth layers is noted with chalk marks on the pit wall. As Master Bell founder Mr. Mabalon emphasizes, they use pure topsoil, which becomes as hard as concrete due to the casting heat, and thus prevents the casting pressure from bursting the shell. Layer by layer, the molders must smooth the earth with a shovel, then compact it with electric tampers, and this process takes 3 days. After 2.5 days, only the windpipe systems protrude. Now onto the casting channels. From the furnace, the pit is reached via a pouring bridge mounted on the bunghole of the metal chamber. On top of the pit, the molders build a channel system of bricks. For the construction of the main and side channels, the path is previously marked with chalk. The bell founder can never cast more than one bell at a time, so the side channels are closed with iron plates to allow the incoming metal to flow through one bell mold at a time. The channel must be sturdily built to withstand the pressure of the cast metal. And it must also be high enough to allow enough metal to flow in. The brickwork channels are lined with clay. And then the founder applies a layer of graphite. This is intended to prevent the molten metal from sticking and adds a thermal layer. Loading the furnace. For casting the bells, approximately 4,100 kilograms of casting material or bell feed is needed. The alloy is prescribed by the Limburg guidelines for the tonal assessment of bells. According to these, tin bronze bells must be cast exclusively from genuine bell bronze, 78% copper and 22% tin. It may not contain more than 2% foreign matter. The proportionate amount of bronze ingots, calculated based on size, is placed in the metal chamber. At the end of the nightly casting preparations, the molders fill the channel system with prepared briquette fire, so that the clay and graphite cure before the casting the following afternoon. The casting. It is Friday morning, 110 days after the molding work began. The plume of smoke from the chimney of the Mabalon bell foundry indicates that the casting furnace is fired. The schedule for the busy day is precisely planned. After every hour and a half, the men have to clear the furnace grate, adding beechwood logs and tons of coal until within 5 hours, the metal has heated to 1,150 degrees Celsius. The temperature in the furnace's combustion chamber is then around 2,000 degrees Celsius. After the fourth set of wood and coal, it's time to add the pure tin to achieve the required copper tin alloy. Pure tin only needs to be added shortly before casting, as its melting point is much lower than that of copper. Casting always takes place on Fridays for a very practical reason. Once the hot casting is in the mold, it solidifies only slowly, and any external vibration could undo the entire work. The least vibration is to be expected on weekends, as no machinery is in operation. Shortly before the actual casting, the metal bath is checked again and any floating slag is removed. After the master bell founder has tapped the furnace, the metal flows into the main channel. From there, the formers gradually channel it through the side channels to the 5-bell molds. Each former has their position and their assigned task. Draining the slag. Removing the slide to allow the bell feed to flow into the branch channel. Pulling the rod out of the pouring hole so that the bronze can fill the mold. Digging out the bells. 5 days later, the bell is lifted from the pit. Over the weekend, the bells in their molds have cooled sufficiently, and on Monday the molders could clear the channel system and begin digging out one bell after the other. Today it is the turn of the last bells. In just a few moments, Hans removes the shell, which was painstakingly formed to get at the newly cast bell. This moment is called the actual birth of the bell. Here the bell sees the light of day for the first time. Excitement awaits. Now it will be revealed whether the months of work have been worthwhile. Members of the Marzig parish also do not miss the event of the bell birth. The bells are not yet completely cooled down. They are still lukewarm. Hans pushes the core out of the bell's interior, and the supports on which the sand bed for the clapper ring was applied are also exposed. The bell is a musical instrument. However, it only rings when the clapper strikes its edge. Its tonal purity must be tested. The Limburg guidelines already cited stipulate that bell founders are not allowed to deliver new bells to parishes without official acceptance. It will take another 3 weeks before the bells can be presented for this test. Bell testing. A representative of the diocese responsible for the parish checks the tone and sound quality. He enters the results in the acceptance document. The bell expert strikes the bell with a handmade adjustable tuning fork to measure the tone. The expert lets the new bells ring for the film documentation.